back. Today we're going to look at the second half of 3.5, which is dealing with solving nonlinear systems, especially looking at circles. Now, a circle in its general form is x squared plus y squared equals radius squared, where its center is 0, 0. That would be the parent function. So what we're going to look at today is different types of circles. So we have x squared plus y squared equals 10. And we have y equals negative 3x plus 10. Okay, so what we're going to do is we're going to solve this by using substitution, and that is the method of choice when dealing with circles. So what we're going to do is we're going to take what y is equivalent to and substitute it in for y in the first equation. Now when we get that, we get x squared plus 3 times the quantity, negative 3x plus 10 parentheses squared equals 10, because it was y squared. Now, if you remember, this is a binomial squared, so you could use a formula for that, or you can just write it out twice. Negative 3x plus 10 times negative 3x plus 10. Since you have two sets of parentheses, then you will need to FOIL that. Negative 3 times negative 3 is positive 9x squared. Negative 3x times 10 is negative 3x. 10 times negative 3x is negative 30x, and 10 times 10 is 100. We combine the like terms on the left. We end up with 10x squared minus 60x plus 100 equals 10. Well, we know we're solving this, so it has to equal 0. So I'm going to subtract the 10 over. I get 10x squared minus 60x plus 90. Now, those problems look pretty big. They are all divisible by 10, so I'm going to go ahead and divide them all by 10 just to reduce the math problem into something a lot simpler, which is x squared minus 6x plus 9 equals 0. Now from here you have some options. You can complete the square, you can factor it, you can use the quadratic formula. Very easily it factors of 9 that give you negative 6 or negative 3 and negative 3. Set those equal to 0, you just get x equals 3. Now just like before, when solving a system we have to substitute it back in. First equation doesn't look the greatest, so we're going to do the second equation. So we're going to do x equals 3 into the other one. So y equals negative 3 times the quantity, 3 plus 10, which is equal to 1. So my point of intersection is 3, 1. And if I were to graph it, that is what the graph would look like. You have a circle with a radius a little less than 4 in your line, and they intersected that exact 1 point. Let's just do one more of those so you can see it once again. So the second one we're going to do is x squared plus y squared equals 16. So that would be a circle that's at 0, 0. And since it's radius squared, it'd have a radius of 4. If you want to imagine what that looks like. So step 1, just like before, we substitute in y. We write it twice. Remember, if at any point I'm going too fast, you can pause the video. We FOIL. We get x squared minus 4x plus 16. We combine like terms. 1x squared plus 1x squared is 2x squared. Negative 4x and negative 4x make negative 8x. 16 equals 16. We move over our constant. Ooh, that should be 0, not 10. Okay, divide everything by the number in front if possible, which is 2. We get x squared minus 4x equals 0 divided by 2, which is 0. Now here I could use the quadratic formula. A is 1, B is negative 4, C is 0. I could complete the square, or I could realize, hey, they just have an x in common, so I'm going to factor out an x. I set each factor equal to 0. So x equals 0 and x minus 4 equals 0. I get x equals 0 and 4. That doesn't mean the order pair is 0 and 4. That means it's going to hit somewhere at 0 comma something and 4 comma something. I substitute in 0 into my two equations. I get 4 as an answer. I substitute that 4 into those equations. Now it's kind of funny because this time you get 0. Now, are they always just going to be the inverse of each other? No, that's just how it happened this time. So when I substituted in a 0, I got a 4, and when I substituted in 4, I got a 0. So my two answers are 0, 4, and 4 zeros. So if I were to graph these, I would have a circle and basically lay a line cutting through it and intersecting at two different points. Now, the other basic idea we need to talk about is solving equations by graphing. There is kind of a shortcut. Some of you were solving last class period. You would have y equals and y equals, so you were like, well, they're equal to each other, so I can just set them equal to each other and solve, which is of one benefit. But it works both ways. So to solve an equation, whether or not it looks like two functions, you can actually separate it into two functions. It says by graphing the left side separate from the right side and figuring out where they intersect. So I'm going to kind of show that to you. I did these on Desmos. So my equation is 3x squared plus 5x minus 1 equals negative x squared plus 2x plus 1. So I look at this problem, I would start moving everything to one side, solving it, all that fun stuff. But what you can realize is that even though it doesn't have a y in it, since they're equal to each other, we can actually separate these into two separate problems. So in order to do that, we introduce the idea of y equals. So what we're going to graph is y equals 3x squared plus 5x minus 1, and y equals negative x squared plus 2x plus 1. Now when we do that, we get something that looks like this. Now here's the catch. When you look at these, the 2 points in intersection, I just clicked on Desmos at those points. If the original equation does not have a y in it, you do not list them as an ordered pair. So the answers to this problem would be approximately x equals 0.425 and x equals negative 1.175. So sometimes things that are not looking linear, you can actually, or quadratic, you can actually set them equal to y since they're equal to each other and use that inverse idea of if they're equal to y, both equal to something, they're equal to each other, using that idea to work the other way too as well. It's called the transitive property. So, for example, I got this messy problem up here. Maybe I'm just wanting to check to see what x is. If they're both equal to each other, then maybe I could intersect and put them in as a y. So I did that. So I did y equals negative parentheses x minus 1.5 squared plus 2.25. And then on a separate line, I did y equals 2x times x plus 1 at 1.5. And when they graphed, I clicked on where it looked like they intersected, which is right here, which is at 0, 0. So the answer to this math problem is not 0, 0. It's just x equals 0. Because even though it didn't start with a y, we don't list a y as the answer. We only list the x. So I kind of hope this is helpful. A little bit of a shortcut to help you once in a while as you're going through problems if you have computers available for you to use. And that's pretty much it, guys. So that's the end of section 3.5. So now you have an assignment that corresponds to that in 3.5, and that is it for the day.